up to 80 feet deep, all the way down and into the underlying bedrock layer.
Each of these columns, they're designed to go in and sit on the bedrock. The concrete will set up within this column underground, and the skin friction or the resistance of the concrete against the rock is what will hold the bridge up and support the load that the engineers have designed it for.
But up to 25 feet of hard ground lies between them and the bedrock. Crews attach a 48-inch bullet-tooth auger bit to the load drill shaft to bore down and gouge the earth out. Invented by the Romans, the auger took a huge step forward around the 14th century with the development of the crank-handled carpenter's brace. The handle is shaped in such a way that holes can be drilled using continuous rotation. Sharp teeth on the front edge of the helix-shaped blade rotate into the wood, and the spiral bit design carries the shavings up the borehole to the surface. Once it strikes bedrock, the crew retracts its auger bit and slides a steel casing tube into the hole to reinforce its unstable dirt walls. The casing tube is 20 feet long and difficult to maneuver over the unstable hole. The load drill attach is designed for boring, not lifting. So here's where it needs some help. Cue the Terex RT555 crane. To get a solid footing for the bridge supports, the crew has to drill a socket 8 to 10 feet into the solid rock, an almost impossible task for the bullet-tooth auger. To get this job done, the crew arms the load drill with a 1,200-pound, 48-inch rock core bit, a hardened steel tube edged with tungsten carbide teeth, specifically designed for grinding 4-foot slugs out of solid bedrock very, very slowly.
I'm not here to inspect and double-check our drilled shafts. We want to test the rock socket and make sure that we're comfortable with the competency of the bedrock and make sure that it meets our design requirements. Most of the rock around here is calcareous or limestone-based. We have a lot of solution cavities, a lot of caves and voids, and because of that, you can't count on real competent bedrock.
Chris gives the high sign. The shaft and bedrock are fine. The load drill crew now moves on to the next column, while another team preps the hole for concrete. All the water in the bottom of the hole will be forced out by the denser concrete as it fills the hole.